Welcome to the deep dive, where we sift through the sources, extract the most important nuggets, and, well, bring you surprising facts with maybe a dash of humor. Today, we're embarking on a deep dive into a topic that might initially sound completely absurd, almost, comedic.
Yeah, a little bit out there.
But it actually holds a surprising amount of intellectual weight. We're talking about weight itself, specifically in commercial aviation.
Right. And it's an area of, truly obsessive focus for airlines, and it has been for decades. You might have heard the famous anecdote about American Airlines saving tens of thousands of dollars annually just by removing a single olive from each first-class salad.
The single olive. Yeah, I remember hearing that.
Exactly. And that wasn't just some, quirky cost-cutting thing. It was a really potent symbol of how crucial every single gram is when you're, propelling hundreds of tons through the sky.
And that olive story, it sets the perfect stage for our mission today, actually. We're going to take that obsession with weight reduction to its most extreme hypothetical conclusion.
Okay.
Our goal for this deep dive is to quantify the total societal savings in fuel, cost, carbon emissions if every single air traveler adopted a truly radical universal weight minimization protocol.
It's a wild thought experiment, yeah, definitely.
Yeah.
But it's one that allows us to rigorously analyze the sheer power of, marginal gains when you scale them across billions.
Billions of people, yeah.
We'll be exploring three, unconventional actions passengers would take. Everything from what's on your head to your internal digestive system.
Okay.
And even what you wear.
So settle in, but maybe don't get too comfortable. We're trying to keep things light. Because while the premise is unconventional, the analysis it prompts is a serious intellectual exercise. It'll illuminate the incredible efficiencies at play in global aviation.
Yeah.
Let's unpack this.
Okay. So the core principle is remarkably straightforward. An aircraft's weight is directly linked to its fuel consumption.
Right.
For a plane to stay airborne, its wings have to generate lift equal to its total weight. Simple physics.
Makes sense.
But when that weight increases, more lift is needed, which in turn creates more induced drag.
Induced drag. Okay, what's that exactly?
It's essentially extra resistant the plane experiences, sort of like a subtle braking force because of the way its wings are generating all that additional lift.
Ah, okay.
And to overcome that increased drag and maintain speed, the engines need more thrust. And more thrust, of course.
Means burning more fuel.
Exactly. It's a cascading effect. Every kilogram added just creates this ripple.
And that's precisely why fuel costs are such a massive expense for airlines. I mean, we're talking...
Oh, huge. Yeah. 25% to 40% of their total operating costs. Easily.
Wow.
So any reduction in weight, it just directly translates into significant savings and, improved profitability. This isn't just about being green. It's absolutely critical for the bottom line.
Right. The economics are undeniable.
You've hit on a crucial point there. For our analysis, a robust and actually quite conservative baseline, used widely in the industry, states that a 1 kilogram reduction in an aircraft's total weight saves approximately 0.0003 kilograms of fuel for every kilometer flown.
0.003 kilos of fuel per kilo of weight per kilometer. Got it.
That specific factor gives us a precise way to calculate the impact.
And here's where the physics gets even more, clever. There's this positive feedback loop happening too, right?
Exactly. That's a great point. If you reduce the payload weight, like the weight of passengers, that means less fuel is needed for the flight itself. Simple enough.
Okay.
But less fuel means the aircraft is inherently lighter at takeoff, which further reduces the fuel needed to carry that initial fuel load.
Right, because the fuel itself has weight.
A lot of weight. Think about a massive aircraft like a Boeing B-52. Its fuel load can actually be heavier than the empty weight of the aircraft itself.
No kidding.
Yeah. So our calculations, while, we're trying to be precise, they're actually on the conservative side because they don't fully account for this compounding benefit.
Interesting. Okay.
Exactly. So now let's delve into how the individual elements of this hypothetical minimalist passenger protocol. We've got a few rather unconventional suggestions for how a passenger could shed that weight.
All right, so our radical passenger protocol, 3 main components. Let's start from the top. Literally, what's the deal with hair?
Indeed. The first element is what we're calling the follicular factor.
The follicular factor, okay.
Imagine a world where every air traveler adopts the universal buzz cut.
A buzz cut. Everyone.
Everyone. While it sounds extreme, hair has measurable weight. Research suggests a full head of hair, depending on length and density, of course, can weigh anywhere from 60 to 100 grams.
60 to 100 grams. Okay, not a huge amount individually.
No, but for our calculations, we're using a conservative average of 80 grams, or 0.080 kilograms, for the per passenger hair weight saving.
80 grams. It might seem minuscule, but like you said, remember that, Olive.
Exactly. It all adds up.
And then we get to an even more, shall we say, intimate area, the pre-flight prep. This one really pushes the boundaries, doesn't it?
It really does. We're talking about the pre-flight purge.
The purge.
A regimen of fasting and laxative use to minimize the contents of the digestive system.
Whoa, okay. So 2 elements of saving here. Evacuated solid waste and avoided food intake.
Precisely. For solid waste, medical sources indicate an individual typically produces about 0.40 to 0.45 kilograms of feces daily.
Okay.
We'll use 0.425 kilograms for that component.
425 grams.
Yeah. And if a passenger fasts, they're not consuming, say, 2 standard airline meals, which we estimate at about 0.250 kilograms of food mass each. Quarter kilo per meal.
So half a kilo saved from just not eating those 2 meals.
Right. An additional 0.50 kilograms of avoided weight.
Yeah.
So combined, that's a saving of 0.925 kilograms from digestive contents alone.
Almost a full kilogram just from all
Yeah.
that. And this directly mirrors that American Airlines olive logic, right? I mean, from a physics perspective, a kilogram of undigested food in a passenger is treated exactly the same as a kilogram of cargo or catering equipment.
Absolutely.
Yeah.
It all adds to the takeoff weight. Doesn't matter what it is, just that it is weight.
Right.
Finally, we have the minimalist wardrobe.
Ah.
The protocol suggests replacing a standard travel outfit with just minimalist swimwear Speedos or bikinis.
Okay, so no bulky jeans, no sweaters, just the bare essentials. What kind of weight are we really talking about here for normal clothes versus swimwear?
Well, a typical male travel outfit, jeans, t-shirt, maybe a sweater, shoes, averages about 2.35 kilograms.
Over 2 kilos.
Yeah. For a female outfit, it's usually a bit lighter, around 1.55 kilograms.
Okay.
Averaging those gives us a baseline of 1.95 kilograms for a standard travel outfit.
Almost 2 kilos on average.
Right. Now, in stark contrast, a minimalist bikini or Speedo weighs in at about 0.15 kilograms. Maybe less.
0.15 kilos, that's a huge difference.
It is. That means a substantial saving of 1.800 kilograms per passenger from clothing alone.
Wow. Okay. So, let's add this up. If we consolidate these figures, 0.080 kilograms for hair.
80 grams.
It's 0.925 kilograms for the digestive contents.
Yeah.
And 1.800 kilograms for clothing.
Right.
That brings our total per passenger weight saving to an impressive 2.805 kilos.
2.805 kilos, almost 3 kilos per person.
Right. Now, let's scale this individual saving to a global level. This is where the numbers truly become, well, mind-boggling, I expect.
Absolutely. First, we need our global baselines. The International Air Transport Association, IATA, forecasts 4.779 billion global air passengers for 2024.
4.779 billion. That's a lot of people flying.
It is.
And how do we figure out the average flight distance for all those passengers? Because flights vary wildly, right? Short hops, long hauls.
Good question. To figure that out, we look at something called revenue passenger kilometers, or RPKs.
RPKs, okay.
Think of it as the total number of kilometers flown by all paying passengers combined in a year.
Gotcha.
With RPKs projected to hit 8.8 trillion in 2024.
8.8 trillion.
Yeah. And our 4.779 billion passengers. You divide one by the other, and that gives us an average flight distance of 1,841 kilometers per passenger trip.
1,841 kilometers. So that global average accounts for all those short regional flights and the long international journeys.
Exactly. It balances out.
All right. So we have 2.805 kilograms saved per passenger. We know every kilogram saved on the aircraft saves 0.003 kilograms of fuel per kilometer flown. We've got the number of passengers, the average distance. So what's the truly astonishing outcome? What's the total fuel saved?
Okay, so you multiply it all out. The saving per passenger times the fuel saved per kilo per kilometer times the average distance times the number of passengers. When you scale that individual 2.8 kilograms across nearly 5 billion annual passengers, you arrive at a truly mind-boggling amount of saved fuel. Over 74.03 billion kilograms annually.
74 billion kilograms of jet fuel.
Billion with a B.
Just letting that sink in for a moment. That's an immense amount of fuel. How can we even visualize that? Like in gallons or liters?
Yeah, to give you a sense of scale, using the density of jet fuel, that's enough to fill nearly 93 billion liters, or a jaw-dropping 24.45 billion U.S. gallons of fuel.
24.5 billion gallons. That's just a truly immense volume.
It is. It really shows the power of scale.
So what does this all mean then for our society, economically and environmentally? What's the impact?
Well, let's break it down.
From an economic standpoint first, what's the monetary value of that saved fuel for the airlines, all those billions of gallons?
Right. Jet fuel prices fluctuate, obviously, but using a conservative mid-range price of, say, $4.50 per U.S. gallon.
Okay.
Those 24.45 billion gallons of saved fuel translate into an astonishing $110.03 billion in annual cost savings for the global airline industry.
$110 billion?
Billion dollars, yeah.
Yeah.
That figure alone truly underscores the incredible financial incentive here for airlines to prioritize fuel efficiency. It's not just nice to have, it's fundamental.
$110 billion in savings. That's absolutely massive. And what about the environmental impact, the carbon footprint? That's got to be huge, too.
The environmental dividend is equally significant, maybe even more so, depending on how you look at it. For every 1 kilogram of jet fuel burned, approximately 3.15 kilograms of co-euro are released into the atmosphere.
Okay, about 3 times the weight in CO2.
Roughly, yeah. So applying that to our 74.03 billion kilograms of saved fuel, we're looking at a reduction of 233.18 million metric tons of co-euro emissions annually.
233 million tons of CO2. How does that compare to, like, total aviation emissions?
Well, to put that into perspective, global passenger aviation was responsible for about 747 million tons of co-euro back in 2018. That's a commonly cited figure.
Okay.
So this hypothetical saving represents a staggering 31.2% of that total.
31%, just from this extreme passenger weight loss.
Yeah. It really shows the enormous leverage. Even seemingly small change. Well, 2.8 kilos isn't that small individually, but you know what I mean. The leverage they can have when aggregated across billions of journeys.
That's incredible.
And let's not overlook the sustainable materials bonus from our protocol. Remember the swimwear?
Ah, right. The Speedos and bikinis, they had to be sustainable.
Exactly. While the primary savings are obviously from the weight reduction during the flight itself, this adds a secondary ground-based environmental benefit that often gets missed in these kinds of discussions.
That's right. Because the manufacturing of traditional textiles, like conventional cotton or virgin polyester, carries a huge environmental burden, right? Energy, water, emissions.
Exactly. Organic cotton, for instance, produces something like 46% less co-euros than conventional cotton during its production. And recycled polyester, made from old plastic bottles and things, can reduce greenhouse gas emissions by nearly 70% compared to making virgin polyester.
Wow, 70%.
Yeah. So if billions of articles of clothing are shifted to these sustainable materials, that's a significant separate environmental win just in the manufacturing phase. Totally separate from the flight savings. It's more of a holistic life cycle view.
So these incredible numbers, they paint this picture of what's theoretically possible with extreme passenger adjustments. But, you know, as fascinating as that thought experiment is, and it really is fascinating, it's clearly not the practical path forward, is it?
No, not at all. Universal buzz cuts and pre-flight purges are, well, they're not happening.
Right. So let's pivot now to what's actually happening and what the real drivers of aviation decarbonization are likely to be.
You're absolutely right. Well, the numbers from our thought experiment are immense, and they prove the principle. The true path to net zero aviation lies in technological and operational revolution, not personal sacrifice on this kind of, frankly, absurd scale.
Okay.
And the industry is making incredible strides in several key areas.
Okay, let's talk about the big technological leaps then. What's happening with the aircraft themselves, the airframes? You mentioned composites earlier.
Right. The most significant and, importantly, permanent gains come from improvements in airframe and engine technology. Modern aircraft are already up to 20% more fuel efficient than the ones they're replacing.
20% is a big jump.
It is. And for airframes, like you said, we're seeing extensive use of lightweight, high-strength composite materials. Think carbon fiber reinforced polymers. For example, the Boeing 787 Dreamliner and the Airbus A350, they're over 50% composites by weight.
Over half the plane.
By weight, yeah. And just making the wings out of carbon fiber alone can cut fuel consumption by something like 5%.
Wow.
So if every commercial aircraft today achieved these kinds of airframe efficiencies, the total annual fuel savings would easily dwarf our hypothetical passenger protocol. Easily.
Right, that makes sense. And engines, I imagine that's where the biggest gains are made? Or is that too simplistic? What's the cutting edge there?
No, you're spot on. The engines are a massive lever. Huge gains there. Advances like higher bypass ratios.
Bypass ratio. What does that mean in simple terms?
Basically, it means the engine pushes more air around its core, bypassing the combustion chamber compared to the air that goes through the core. It makes the engine act more like a giant, super efficient ducted fan.
Okay, got it.
So higher bypass ratios plus new heat-resistant materials allowing engines to run hotter and more efficiently. It all adds up. The Pratt & Whitney geared turbofan engine, for instance, that's a big one, has demonstrated up to a 20% reduction in fuel consumption compared to previous generations.
Another 20% just from the engine.
Yep. And the next generation of engines, things like Rise from CFM, they're promising another 20-25% more efficiency beyond even today's best. These are systemic, permanent reductions that fundamentally transform the energy needed for flight.
Okay, so better planes, better engines. Beyond the hardware, how are airlines getting smarter about how they fly? You mentioned operational stuff.
Right, that's operational excellence. It's crucial, too. Airlines use incredibly advanced software and real-time data now to optimize flight paths. They analyze weather forecasts constantly to take advantage of tailwinds, avoid headwinds.
Flying smarter, not just harder.
Exactly. They use sophisticated algorithms to find the most efficient altitudes and speeds for every phase of flight, even adjusting in real time. It's about squeezing every last drop of efficiency out of the journey.
I've also heard about something inspired by migratory birds. Formation flying for planes. Is that really a thing being considered?
It is. Seriously. NASA, Airbus, others are actively exploring concepts for commercial aircraft to fly in formation, sort of like geese.
Like drafting and cycling.
Pretty much the same principle. A trailing aircraft can experience significantly reduced drag when it's positioned correctly in the wake vortex, the swirling air coming off the wingtips of a leading aircraft.
Huh.
Initial studies and tests suggest potential fuel savings of 5% to 10% for the aircraft flying in the trail position.
5 to 10%, that's not insignificant.
Not at all. It's truly fascinating to see how nature inspires engineering solutions. Lots of hurdles still, obviously, with air traffic control and logistics, but the potential is there.
Okay, so better planes, better engines, smarter flying, even formation flying, all these are significant steps. But if we're talking about the ultimate lever, the absolute game changer for getting aviation to net zero, what would that be?
That would have to be sustainable aviation fuels, or S.
SF. Right, we hear a lot about that.
Yeah. These fuels are produced from renewable feedstocks, things like used cooking oil, agricultural residues, municipal waste, or even through more advanced processes that capture carbon directly from the air and combine it with hydrogen.
Okay. And what makes them so game-changing?
The beauty of SF is really twofold. First, on a life cycle basis, so looking at production, transport, and use, they can reduce co-Euro emissions by up to 80% compared to conventional fossil jet fuel.
80%. That's massive.
Huge. And critically, number two, they are drop-in compatible.
Drop-in compatible, meaning?
Meaning they can be blended with existing jet fuel up to 50% currently, sometimes more in tests, and used in current engines and airport infrastructure without any modifications to the aircraft or the fueling systems.
So we don't need a whole new fleet of planes to use them. That's huge.
Exactly. That compatibility is absolutely key for rapid, large-scale deployment. IATA, the airline trade body, estimates SAF could be responsible for something like 65% of the total carbon reduction needed for the industry to reach its 2050 net zero target.
65% just from SAF.
That's their projection, yeah. The main challenges right now are cost filled back. SAF is currently, 2 to 4 times more expensive than fossil jet fuel.
Ouch.
Yeah. And limited production. Currently, it's less than 1% of global jet fuel consumption. Tiny fraction.
So how do we fix that?
Well, governments and industry are pouring investment into scaling up production, developing new pathways, and providing incentives like tax credits or mandates to bring down the cost and increase supply. But the potential impact of SAF alone is just orders of magnitude greater than any individual passenger weight reduction scheme we could dream up.
This deep dive has shown us something really incredible, I think. The hypothetical numbers from our radical passenger protocol, that 2.805 kilograms per passenger, translating to $110 billion in savings and 233 million tons of co-air averted, they powerfully validate the principle of aggregated marginal gains.
Absolutely.
It truly shows how every single gram does matter when you multiply it by billions and billions of kilometers.
It does. It really does. But it also underscores very clearly that the future of sustainable aviation doesn't lie in asking passengers to shave their heads or wear Speedos on a plane.
Thankfully.
Yeah, thankfully. The real path forward is revolutionizing the aircraft itself, the materials, the aerodynamics, the engines, and, crucially, the fuel that powers it.
So the collective action required isn't really from individuals fasting before a flight, is it? It's from the engineers developing those 25% more efficient engines.
Right.
From the data scientists optimizing flight paths minute by minute.
Right.
And from policymakers and investors collaborating to scale the production of those sustainable aviation fuels that can cut life cycle emissions by 80%.
Exactly. The thought experiment we just walked through, as extreme as it was, perfectly illustrates the sheer scale of the prize. The industry's real-world strategies, the tech, the ops, the fuel, that's how we actually claim that prize, by tackling the problem at its structural roots, not just fiddling with its superficial manifestations.
Yeah. This deep dive, as absurd as its premise was initially, it brilliantly highlights kind of paradox. The areas where we personally feel we can make a difference, like recycling that one bottle or maybe skipping a straw, they often pale in comparison to the impact of these big, systemic technological shifts.
That's a good point.
It teaches us, maybe, to prioritize not just any marginal gain, but the ones with the deepest ripple effect throughout the entire system. It raises an important question for you, the listener, to think about. Where else in our lives or in society are we perhaps overlooking the aggregated power of marginal gains by focusing too much on the individual action, when the true leverage actually lies in changing the system itself?